Tonight we're looking at Chapter 10, and this is an important chapter in the book, and it covers the concept of inheritance. Inheritance is an extension of object-oriented programming that really, I'm hoping will help to kind of clarify some really important concepts for you. One of the things that's so cool about the Java language is this capability to use objects and classes. And you can see our objectives here. And one of the reasons we cover this chapter is because it's really one of the fundamental things that goes with object-oriented programming. And that is basically because we do not want to write code that we have to write over and over and over again. When we've created it once, why recreate it? Or if a capability exists in one object or class, why reinvent it for another one? So basically, in a nutshell, what this means is that you can create a class file that has certain capabilities and then allow those capabilities to be inherited by other classes and objects as you see fit, so that way you don't have to recreate those things. So code reuse is really kind of an important factor in this. All right, let's talk about these concepts. It says here, a mechanism that enables one class to inherit both the behavior and the attributes of another class. And you'll see that in action. It'll come into view, I think. Apply your knowledge of a general category to more specific objects. Now, that's kind of vague in description, and I think that when we start to do the coding, that'll come into focus a little bit more. But when we're working with objects and classes and we start to throw in what we call superclasses, and we're starting to inherit capabilities, one tool that programmers use, and it's really gaining in importance quite a bit, is this thing called UML. And you can see it stands for Unified Modeling Language. And basically what it is, it's a visual tool of sorts. And you can see on the upcoming slides here that you draw these little boxes and you write down things. And you may have seen these at times throughout the chapter. I know the other book that we use for Java 2 very heavily uses UML diagrams. And the point of a UML diagram is to really, in a nutshell, give you a snapshot of what a class file does, so that you don't necessarily have to dig into the code, but you can look at what that diagram is and very quickly see, okay, well, what capabilities, what attributes are present, what methods are present that we can leverage for our own needs. All right, so let's just take a look at one, for example. Now, it was a while ago that we did a thing about employee salary somewhere, and you probably wrote some code to do some of these things, so these should look somewhat familiar. But what this diagram indicates is that we have an employee class file. Now, this is not an executable file, per se. It is a class from which we can instantiate an object, so we can use that as our blueprint. Now, an employee class apparently has two attributes, and those would be equivalent to the variables that we declare at the top of a class. We usually say like private int employee number. Okay, so what this is indicating to you is what those data attributes are at the top, the data fields, the attributes, the variables, however you want to think of them. And notice how there's a little minus sign there. Then at the bottom, we see the methods that are attached to the class. So it's very typical whenever you have certain data fields or attributes that you can get and set their values. Sometimes you do that through the constructor. Sometimes you do it by directly calling one of these methods externally. So every time I create an employee object based on this class, it will have these capabilities. Now, once again, I'm not looking at the code, but I'm looking at a general overview of what's available to me. So what I would need to pass in to make it work, what it returns, right? The data types, notice the gets will return a value. So what are they returning? They're returning an int, they're returning a double. And knowing that, you can kind of plan things out as you're building your application. These here need values coming in, an int and a double, but send nothing back. So that's kind of the diagram in a nutshell. It's a nice little tool that you can use. And as we start to talk about the final project, you'll see how I'm going to apply that to kind of help you design what you're going to build. Now, if we're going to use inheritance, we are using a capability of creating a class file that also not only has its own features, but can pull the features of a different class into it without having to rewrite those features into the new class that we're making. So notice here that we have the employee class, but we also have one called employee with territory. An employee with territory has its own attributes, so it's got an employee territory and it's integer. It's got a get and a set. The get returns an integer. The set returns nothing, but it takes an integer in as a value. So there's a relationship here in that we would be able to use employee with territory to extend the capabilities of employee. And really the way that we do that, and it can go in either direction, mind you. But you have one class that has certain features, and then if you want the class that you're creating to also have those features, I would say something to the effect of employee with territory extends employee. So if I were to create an instance of employee with territory, it would automatically have all these capabilities as well. That's kind of cool, right? And I don't have to rewrite it. Those capabilities were already created. So if you just think of it in those simple terms, it's kind of cool. It instantiates as it would any other object. So you would create these capabilities in your object and these capabilities in your object. They all follow each other. And all you have to do is use that extends keyword. So why do you use this? Save time, reduce errors, and it says reduce the amount of new learning required to use a new class. Well, I've already created it. I know what that class does. I don't have to rewrite it. I don't have to copy the code and paste it into my new class. It's already there. All I have to do is grab the class file, drop it into the same folder, and call it. That's all there is to it. All right. In terms of terminology, and I'm going to tell you right now that when it comes to this inheritance concept, you'll hear people calling things by different names but meaning exactly the same thing. So I'm going to try to point out as many as I can. All right, so we look at the term base class. So the base class would be the one that we're pulling from, the one that sits, as they indicate here, as a parent class or a superclass. And then if we're creating our new object and we're extending those capabilities of that class, the one that we're extending from is the base class, superclass, or parent class, right? Because you inherit from the parent, right? Think of it that way. A derived class is also known by the names of subclass and child class. Parent-child works good for you, stick with that. If superclass, subclass works for you, stick with that. Whatever terminology you're comfortable with. All right, so one of the keywords that we use, which I already alluded to, is a keyword called extends. And notice this does exactly what I was mentioning before, where we have the class that we're creating. So we're creating employee with territory, and it extends employee. So employee with territory has all the capabilities of its own and grabs all the capabilities of its parent or its superclass or its base class and adds it to its own. All right. It says here, inheritance is a one-way proposition. A child inherits from a parent, not the other way around. So the employee class, if I was just to create an employee object off of employee, it will not grab the features of the child class. But the child obviously can grab the features of the parent class. So take a look at a little bit of code example here. So we already saw what the UML diagrams were, but the employee with territory, if we turn that into code, and we can look at that UML diagram that we have to kind of help build this, because it said that we have an attribute or a data field called employee territory. That's an integer. And then we have a get and a set. The get returns a value. What does it return? It returns an int. The set sets a value. It receives an int but returns nothing. That's why there's a void. All right. So you guys already have learned a little bit about overriding methods, right? You guys remember that? Where you can send in a different number of parameters and depending on, or arguments, and depending on the number of arguments you send in, different constructor classes will execute. And you can override those methods. So by doing that method and overriding from a child all the way up through the parent, we also have this thing called polymorphism. All right. So this is called using the same method name to indicate different implementations. So if you think in terms of how overriding a method worked, and I don't know if you guys do remember this or not, and I think we did it with, I don't remember the exercise it was. Maybe it was the characters, how many eyes it has, or overload. Was that the program name?
We were doing overloads, not overrides.
Well, they are actually overrides. Okay, well, this is basically the same concept. All right, so we have methods where we can send in different amount of arguments and have it behave in different ways depending on what we're sending into it. Of course, you have to set it up so that it does that, but if you have a little bit of foresight, you can do a lot of really neat things. All right. All right, so here it says override the method in the parent class. So we can create, it says a method in the child class that has the same name and parameter list as a method in its parent class. Now, that means that if we run that method in our program, it will first look to the child before it looks to the parent. Local takes precedence. Kind of like CSS in that capacity. All right. And it says here, the ability of one method name to work appropriately for different subclass objects of the same parent class, that is subtype polymorphism. Now, with the applications that we're going to write, we're not going to get too deep into polymorphism, so I just want to give you a little bit of a flavor of that. And when you get to your Java 2 class, that'll become much more of a factor. All right, so when you go through the process of actually constructing an object when you're extending a superclass, so let's say we have employee with territory, and then in my program I would do something like new employee with territory, would send in whatever parameters we send in and it creates the object. It is using that superclass to create an object that has all those capabilities, even though we're not calling employee, it still pulls in those capabilities. So keep that part of it, firmly in your head. Now notice it says here that when you do this, the superclass constructor must execute first. So the employee is created, the child is added. It's just like a parent-child relationship. Parents got to be born before the child's born, right? Otherwise, how do you inherit its capabilities? You can't. All right, take a look at a little bit of code here. And the one thing that I think is kind of interesting, thus far we've learned that class files should sit as separate files. You can, in the body of a program, create a class within the program itself. So what you're seeing here, it's like, oh, this must be 3 separate programs. No, you can actually put class files within a class file. And sometimes you do that just because it's more convenient than creating a separate file. But if you know that you're going to create something and then end up reusing it, you may as well make it a separate file, or you can move it to a separate file later and then carry those capabilities with you. But if you watch what happens here, we have a class file called the superclass, right? It doesn't really do much aside from do an output. It doesn't have any data fields. It doesn't really have any methods aside from this. So if I'm to call a superclass with parentheses, it's going to do a system out print line. Then if we create a subclass, and they call it a subclass, which extends a superclass, we then have the capability to do this. Once again, there's no data fields, no attributes, no methods aside from putting something on the screen. Then we create a regular class file that's got a main method, so something that actually executes. It's an executable. And within that, we create a new instance of a subclass, which of course extends a superclass. So we say a new subclass, what's going to happen? Well, first thing it's going to do is it's going to kind of climb up through this and go, well, a subclass extends a superclass, so I better go up to the superclass. So then it will look at this output, look at this output, and execute that. So if you see the output, it's going to be a superclass constructor and then a subclass. So it'll do it in that order. So you see how it's pulling a capability of one thing from another. Now, we do a lot of, in Java, coding where we import libraries to do certain actions, and that's exactly what we're doing. We're pulling in those libraries. They already have all this stuff created. We're just using the capabilities that somebody already made for us. So when you start creating your own classes and you start reusing them and you know what capabilities are there, all of a sudden you're using the syntax that makes a whole lot of sense. It's like, okay, we got an employee with territory, one just builds right off of the other and you get all those capabilities. All right, some constructors will require arguments. You're going to see I'm going to go through this a little bit quickly. Depending on what those constructors are, you may or may not be sending in some arguments to trigger certain things to happen. As we've seen already, you can have default constructors that have nothing going in. You can have constructors that have certain variables coming in, and you can leverage that to your advantage. Now, you can actually override some of the capabilities of the superclass by using this keyword. So you can use the super keyword, and it says here to access the parent class method. And you'll see in this slide here that if I want to directly access the super class capability, so let's say the display method, I can use this, whatever the superclass is called, I can use that keyword super, and it'll go, instead of looking inside preferred customer, it will look in customer to do the display. And the other thing that you need to think about here is because we're instantiating an object and we give it a name, we can also, in this spot here, we can also substitute the name of the object that we instantiated. But because this is a class file unto itself, in order to use the method from the superclass, we just say super, and it'll pull it in. Okay, this is not an executable program. This is not where we're creating the object. This is just how we're defining the object. Okay, here's a little bit of a thing that might be helpful for you as well. I know that this keyword is a little bit confusing, right? Because what does it refer to? Itself.
Yeah.
Okay? All right. So it says here, think of the keyword this as the opposite of super within a subclass. So instead of referring to itself, it's referring to the thing from which it came. Okay? And let's leave it at that. One of the advantages, of course, of using inheritance is the fact that you have this capability of what we call information hiding. And that's a relative term, frankly. Like when we do imports of libraries, we're not really running out to the library and digging through all the files to find the class file that we're using and then look through all the methods and see which one and what it does. We just kind of use it. We're told how to use it. We just use it. We don't have to necessarily dig for the code. So one advantage to creating superclasses is that we're simplifying what we're working with by not having to look at the code on the back end. All right. They have a little bit of an example here of that. And now if you look at this, you're going to say, what is the part that's being hidden exactly? What is being hidden? Is anything being hidden? What? The GPA. Why is it being hidden?
I don't know, because the teacher doesn't want everybody to know what everybody else knows, perhaps?
Okay, yeah, you're thinking of the rationale behind why you would do it.
Yeah.
Right, absolutely. You wouldn't want everybody to know what somebody else's GPA is. But the other part of that is, notice that these are marked as privates. So they're not necessarily directly accessible aside from the object itself. So it helps to block it from outside. All right, and that's exactly what we just said. There's also this level of keyword too. We've mostly seen public and private, but there's also protected, and notice what it says, provides an intermediate level of security between public and private. And you can use it in a number of different methods. That's not something we're going to focus on too much here, but I just want you to be aware of the fact that it's out there. All right. Some of the methods you cannot override, static and final methods, you cannot override. All right, and I'm kind of fast forwarding here with intent, and I think this is about all the slides I'm going to cover here, just very simply because that's all you really need to get your work done at this point. So that's going to wrap the Chapter 10 PowerPoint lecture here, and the next thing we're going to do is we're going to dig in and do a little bit of code and put this into practice.